Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present our Univariate modeling technique projects, which is one of our continuous assessment in STA570. This project will present about the Petronas gas Berhad, or we can call it as CS2904KL in Bursa, Malaysia. In completing this project, there are consists 4 members. We will start with our leader, Muhammad Aiman bin Muhammad Zaidi, with help of his 3 teammates, where there are Ahmad Naim bin Abdul Halim, Nur Afiqah binti Ismail, and me, Muhammad Hafizuddin bin Muhammad Hanif. To introduce our Petronas Gas Berhad company, we will take their official information from their official website at www.petronasgas.com. This company started in the main market of Bursa, Malaysia on 4 September 1995, where 16.60% share owned by them, while the balance held by investors and retail holders. Their main activities are processing natural gas pipe and supplying steam, power, and industrial gas. Current board of directors is Adedan Zainul Abidin as their chairman and Abdul Aziz Osman as CEO for this company, with help with several non-executive directors. The important reason to forecast Petronas gas Berhad because the rising global oil price during increasing COVID-19 vaccination and anticipate higher world economic growth rate in 2020 are brightening the outlook for Malaysia oil and gas sector, said Thomas Wong to the Star newspaper.
Research objective for this project is, first, to study the pattern of close price for Petronas Sendirian Berhad from 13 January 2021 until 11 August 2021. Second, we need to determine the most suitable model that describes the close price of Petronas gas Sendirian Berhad from 13 January 2021 until 11 August 2021. And the last one is we want to forecast one step ahead of the close price of Petronas gas Sendirian Berhad.
For this project, we use adjusted close price of Petronas gas Berhad data. The data is between 30th of January 2021 until 18th of November 2021. The graph shows that there is a trend component and irregular component, whereas there is no seasonal component and cyclical component. For the method analysis, we use 4 methods to find the best fit model. For the first model, naive model, the technique is to take the last period's actual and use it as period's forecast. It works best when the actual historical data series contains no discernible pattern. The formula is Ft plus m equal to Yt. Next model we use is average change model. The model is more stable and practicability. The response relatively quickly to change in the actual time series. The formula is Ft plus m equal to Yt plus average of change, where average of change is the summation of Yt minus 1 and Yt minus 1 minus Yt minus 2 will be divided by 2.
Exponential smoothing techniques is the most widely used class of univariate time series modeling technique. Why? It is extremely simple to understand and to apply. So, for single exponential smoothing, it requires one parameter, the smoothing constant alpha, to generate the feeder values and forecast. It takes into account the most recent forecast. However, it requires the retention of only a limited amount of data, where the formula is Ftm equals to alpha Yt plus bracket 1 minus alpha times Ft, where alpha is more than or equal to 0 and less than or equal to 1.
Exponential smoothing is an approach that weighs recent history more heavily than distant history. double exponential smoothing models two components, which are level and trend. That's why we call it as double exponential smoothing. It can model trend components and level components for univariate time series data. Also, we can use it to provide short-term forecasts when your data have a trend and do not have a seasonal component.
As we can see in the slide, both of the line graph does not have a big gap or difference between them because we use one day previous data to be our next day forecast data. As a result, we got 0.0193 for MSC estimation and 0.0369 for MSC evaluation, while for MAPE estimation and MAPE evaluation we got 1.3275 and 0.8151 respectively.
Average change model. The fitted line in this model is more similar with the actual data. This is because it was analyzed by period to period change. They are approximately of the same size. By using Excel, we get our mean square error estimation is 5.340021, while mean square error evaluation is equal to 0.96098. While for the mean absolute percentage error estimation is equal to 3.031698, while mean absolute percentage error evaluation is equal to 1.326808. And we get one step ahead forecast is equal to 16.63.
So, as a result, the one step ahead forecast is equal to 16.48905, while for the parameter alpha, as we mentioned before, 0.694881. For MSE estimation, it equals to 0.0191434, and for the MSE evaluation, 0.0338147. For MAPE estimation, it equals to 0.6423064. Lastly, for MAPE evaluation, 0.7763722. So, as we can see here, the graph for the single exponential smoothing for the adjust close price of Petronas gas, Sendiri and Berhad, the graph for adjust close and fitted is not that far. In this model, the best value of parameter was determined objectively. Why? It is because to choose the parameter value that minimize the errors, where the parameter alpha is equal to 0.694881.
After we have all the values, we can find the MSE estimation, and the formula is the average of total from the first 2/3 data of E squared. And we also can find MSE evaluation, and the formula is the average of total from the last 1/3 data of E squared. Also, we can find MAPE estimation, which is the average of total from the first 2/3 data of absolute value. And the last one, we can find MAPE evaluation, which is the average of total from the last 1/3 data of absolute value. From the double exponential smoothing for the adjust close price for Petronas gas Sendiri and Berhad, we can see that the close price follow closely to the fitted price and it does not have much difference. And the best value of parameter for this model was chosen subjectively, and the alpha was 0.5.
In conclusion, each model, we are talking about naive model, average change model, single exponential smoothing, and double exponential smoothing, where they have their own one step ahead forecast value, mean square error MSE, estimation and evaluation, and mean average percentage error MAPE, estimation and evaluation. Therefore, the model performs the forecast best in single exponential smoothing model. This is because it has the lowest evaluation in mean square error MSE and mean average percentage error MAPE, as they showed minimal error in a good forecast model. That is all for our presentation for Univariate project of Petronas Gas and Berhad. Thank you so much for listening. Assalamualaikum warahmatullahi taala wabarakatuh, and have a nice day.